Before we begin coding anything, I wanted to take a real brief look at the actual application as a comp so that we would be able to better visualize what it is that we're going to be building component by component. So let's take a look at that now. As you can see in Sketch, here is the Seek app. This is what the finished product will look like. On the top, there's this navigation component. Beneath that is this main section. The main section is composed of a results section and a favorite artist section. Inside of the favorite artist section, there are favorites, and inside of the results, there are results, obviously enough. The second view inside of the Seek app is this view. It's the details view. In this view, we have the navigation, but now on the left-hand side, we have the artist details. By default, when we go to the details view, we're going to be in this top albums route, but there is another route for the detail view. Let's take a look at that. Here's the second route, similar artists. Now, as a part of the functionality for the details view, I have two actions. I have this little trash can that I can use to delete a favorite, and I have the back button. This would take me back to the main view. Navigating back to the main view, I can see these little pluses next to the results. If I clicked plus on any one of these results, it would add it to the My Favorites list. So nothing fancy, but that's a basic overview of the app that we're about to create. The very first component that we're going to create in this app is this navigation component. So let's get started. Alright, let's start building the navigation component. The first thing that we're going to do is create a new directory inside of the source directory. We're going to call this the name of the component. From there, we're going to need to create two files. First, the navigation component file. We're going to tell WebStorm to always add all new files to Git. Then we're going to create the spec file. This will allow us to test our application. Now, one thing that I like to do, since I'm always editing back and forth between these two documents, is to split this view. Another thing that's kind of handy inside of IntelliJ and WebStorm is to create custom shortcuts for this behavior. In this case, when I want to split vertically, I want to add a custom shortcut. Let's go ahead and add one for horizontally as well. Perfect. Now when you see my view pane split, you can just assume that I'm using a keyboard shortcut. Now we're going to begin writing this application by bootstrapping a lot of the details inside of the spec controller. These are going to be a little bit confusing outside of context, but just sort of bear with me, and if you don't understand some of these pieces, just feel free to type them out as you see them. They'll make a lot more sense later. I like to structure my dependencies and separate them with little comment blocks just to keep things a little bit more organized. And we're going to begin by injecting a couple of different components from Angular 2 testing. Now we know that we're going to need the it block, the describe block, and the expectation, because all specs rely on these three pieces. Two additional things that we're going to need are something called inject async, and something else called the test component builder. Now a little description about the inject async. The inject async allows us to inject providers into it blocks. It must return a promise, which will resolve when all of the asynchronous activity is complete. The test component builder allows us to inject component instances, otherwise known as component fixtures, inside of it blocks. We're going to be doing both. Now from our app, we're simply going to need a reference to the navigation component. We haven't named it yet, but we do know where it's located. Now let's construct a basic spec. Now, here's where Angular gets a little bit more complicated. Since we need to inject a provider called the test component builder inside of our it block, we're going to need to decorate this a little bit. First, inside of the it block, we're going to use the inject_async class. Here, we're going to pass in an array and that's going to return an anonymous function. And inside of that anonymous function, we want to inject the test component builder, which I'm going to localize to TCB. Now we know that inject_async requires us to return a promise. So let's go ahead and return a promise. And that promise is just our local instance of the test component builder and a method that we can call called createAsync. And then when we pass in our navigation component, it's going to return a fixture, or an instance of that component. Now typically what we're going to want to do is we're going to test something about the HTML partial that's inside of this component instance. So let's create an instance variable that allows us to do that. Now this fixture.detect changes is kind of like Angular's scope digest. It's going to render the HTML inside of the decorated component, inside of our faux DOM. And we're going to expect that that element has some inner HTML that contains the following string. Now let's run these specs and see what happens. Good, the spec is failing, and it's saying that undefined is the reason for this failure. Probably because the navigation component doesn't exist yet. So let's create that. Now I get really tired of typing in the import statement. So let's go ahead and create a shortcut that does that for us. Now what I'm doing here is when I type in IM, it's going to write out this particular string. It's going to set focus inside of this particular part first. I'm doing that because instead of an import statement, until I know what path I'm going to be importing from, I won't necessarily get the benefit of the IntelliSense for the class that I'm trying to import, or whatever the case may be. I need to define a context by which to use this. And click apply. Now let's use this. So IM, and then I'm going to hit tab, and I'm going to import something from Angular 2/core. I'm importing the component. And this is the component decorator. Now I can use this. Now we know about metadata because we've already seen this before. So we're going to need two pieces of metadata. We're going to need a selector, which we're simply going to call navigation. And we're going to specify a template. Since the template for this particular component is going to be pretty small, I'm going to use backticks so that I can create a multi-line string inside of JavaScript. And inside of this, I'm going to create a section tag. That contains an anchor tag. And inside of that anchor tag, I'm going to write out navigation for now. I want to walk us through a couple of errors that are going to happen inside of our spec. So what we want to do is we want to test this navigation component over here. Now, WebStorm is already telling us that navigation is undefined. So we know that something is wrong between the linkage between these two files. That's because we're not exporting our class. Once we export our class, we see that this error goes away, and we can run our spec file. But there's going to be another problem. This is not the error that I was looking for. But a closer look at the syntax inside of my spec reveals a different problem. Let's fix that. As we can see here, the actual string that gets outputted from navigation is this HTML template, so that we know that it is actually getting digested inside of this detect changes method. However, the inner HTML does not contain the word seek. So if we change the inner HTML to now use the word seek and run our specs again, this test should pass. Perfect. Now we have two passing specs. Now let's inject the navigation component into the seek app itself. Now we're going to need some new meta here, because we're going to be injecting a new directive. Now let's import the directive. So we're going to be importing this from the navigation directory. Now let's serve this up. Let's take a look at what's in the browser. As we can see, the seek app component is now loaded inside of the browser. If we take a look at the HTML, we can see that the navigation element is getting rendered as this section with a nested anchor tag and an ID of brand. So we can see that all of this is working correctly. Okay, now that we have the navigation component built, let's turn our attention to building the next two major components, the detail components and the main component. To get started, let's duplicate this navigation component, since it's a really good boilerplate for a simple ng2 component. Alright, now let's update these components. Now let's update their spec files. Now let's run these specs. You can see that one of them is not passing. Looks like the CCAP is the one that's not passing. Turns out when we built our navigation controller, we changed the contents of this component to no longer include some of its old contents. So let's refactor that now. Now let's rerun our test. Perfect. 4 passing specs. Now, as you may have guessed by now, just testing the HTML instead of a component really isn't a fair test of the functionality of these components. Until now, none of our components have had methods that required additional testing. However, the details component is going to need a couple of methods that we're going to want to test. Let's go ahead and include those now. One of the methods that the details component is going to need is a method called getMainImage. Before we create that method though, let's create some shortcuts for ourselves. We often have to type out the describe block, so let's abbreviate that as just DES. Let's define its context as JavaScript. And let's create one for it as well. Define its context. Finally, let's create one for expectations. Now let's use our shortcuts. We're going to be describing a method, or a function. It's called getMainImage. This method should return an image URL from a collection. First, we're going to expect that it's defined. And here we run into a problem. We need a reference of our detail view inside of this describe block in order to test these expectations. And how do we do that? Just like in our inject async above, we can use the inject method after we import it. and inject the class that we want to use. This will give us a local variable. Now we can test that the getMainImage method is present on a detail view controller. Let's run our specs. While they're running, let's modify our live template to include that missing semicolon. Perfect. And our spec is failing. Let's now write some code to get this spec to pass. Now let's see if we can get this spec to pass. Now we're getting a different kind of problem here. There's no provider for the detail view. Now what's the issue? We've injected the detail view, and we've created a local instance of it. There's no reference by which to get this instance inside of this describe block, even though we're importing it into the controller. In order to get a reference of this, we'll need to use another tool called BeforeEachProviders. We can use this to inject instances of our classes into our it blocks. Now let's run our specs and see if they pass. Perfect, we're getting passing specs. We can see that the component detail view has a function, getMainImage, and it's defined. Now let's test the actual behavior. Now I know based on the API exactly what kind of collection we should be testing against. So let's go ahead and create a mock version of that. From the API, these are the properties of an artist object that we'll need to be evaluating. We're going to have an artist object. It's going to have a collection of images, and the collection is going to have sort of a weird syntax for returning the image URLs. In this case, the image URLs that we're going to be passing back are just strings. We want to test that when we pass in this mock artist object, what we get back is actually this fourth value, because that's going to be the largest image size. You can read a little bit more about this in the Last.fm documentation. So let's go ahead and try this. Now one more thing. Since the detail view will always have an artist object, which we can mock here, we'll no longer need to pass in this argument. We'll just expect that it will evaluate the global artist info object and return this URL. Little typo here. There's a deviation from how the API actually implements this. Now that we've added some code, let's test this out. And look at that, a passing spec. Now, what about when these conditions fail? What do we do in those cases? Let's write out a test that verifies that even if the image URL inside of the collection isn't there, we at least get back an empty string. Now let's see what happens. Looks like it's only returning undefined. We can fix this pretty simply though. Let's just create a variable inside of this method that will always return. Now let's try it. Perfect. Now let's add our last method. The last method that we'll need inside of this controller is one that can remove a favorite item by its ID. Now this method is going to require a service, so for now let's just make sure that it's defined. Now let's rerun our tests. Perfect. Now if we remember from the comp, this details view and main view both get injected into the seek component. So let's do that now. Now let's take a look at that in the browser. Perfect. And we can see here that the main view and the detail view are both getting injected into the browser. Because of the way that I have the CSS written, it's a little difficult to see. Now that we have our two main views, we can focus on routing to those two views. You might remember routing from Angular 1. And routing from Angular 2 is pretty much the same from a behavioral perspective, but the implementation is very different. So let's take a look at that. In Angular 1, you could add the ngView directive to a div inside of a view, and you could render your routes that way. In order to provide all of those routes, you could create a run configuration, and then define all of the metadata for each one of those routes. Angular 2 has a very similar implementation. So let's get started. You can see here that I'm already injecting my route config and router directives. Let's go ahead and inject the router directives into our view, as we're going to need them. Now, it may seem counterintuitive, but we're going to go ahead and delete the two views from our directives. We're also going to remove them from the view. Now, just like ngView used to be the directive that we would apply to a div, what we're going to need in Angular 2 is an element called the router outlet. This behaviorally is the same as ngView. Now, how do we tell this component that this router outlet needs to render views? This route config is actually a decorator that we can apply to the seekapp class. Let's go ahead and get started. Now the route config, distinct from the component decorator, instead of taking in an object, will take in an array. This array is going to contain a series of objects. Each one is going to represent a route. Each one of these objects is going to have its own metadata. Here's the metadata for the main view. The path will be the default path. The name is going to be main. The component that we're going to use for this is going to be the main view component. Now let's copy this and use it for our detailed view. The path for this view is going to be details. The name of this route is going to be details. And the component is going to be the detail view component. Now let's take a look at our app in the browser. We can see that the main view is getting injected into the DOM, right here. So that's a good step. Now let's try and add the details path and see what happens. Now we can see that the detail view is the default route inside of the CCAP. So we've now successfully configured our routes. Let's run our tests and see what happens. Predictably, our tests are going to fail. Let's take a look at the failure. There's no provider in the C component spec for the router. So let's go ahead and import one. Now, just like in one of our other specs, let's go ahead and use the before each providers to provide it into the view. Now our tests are failing on another error. It's unable to resolve all of the parameters for router. For a lot of really complicated reasons. It's because router requires some config. In order to get around this, first, we need to import a utility from the Angular 2 core library called provide. This allows us to substitute providers for other providers. In this case, we're going to substitute the default router with a root router. Let's take a look at the syntax for that. This instance of the router doesn't have the same configuration needed as this one. Now, where do we get root router from? We'll be importing it from Angular 2/source/router/router. Now let's run our tests and see what happens. Looks like we still have a bug. No provider for route registry. Let's go ahead and add this one now too. This one can be found at the following path. Looks like we're still not done. Now let's take a look at the error that we're getting. Now it's saying that there's no provider for token router primary component, which is a fancy way of saying there's no real root application here. You'll need to provide one and manually specify it yourself. So let's go ahead and inject this router primary component . and it needs to know what class to use, so we'll be using the provider again. In this case, we want our router primary component to be the CCAP itself. Now let's run our specs and see what happens. Looks like we're getting another error. Now there's no provider for location. Let's go ahead and provide location. And just like that, we have a passing spec. Just to make sure, let's take a look at our element. Perfect, we can see that our HTML is rendering correctly. Now that we have a passing spec, and we can see that behaviorally, this route config is working inside of the DOM, let's turn our attention to the next component in the series. Since the app that we're creating relies really heavily on the data coming from Last.fm, let's go ahead and get started by adding the HTTP service. First, we'll want to create a directory for all of our services. Then, inside of that directory, we'll want to create a file for our HTTP service. Since I know that this service is going to require the injectable decorator, I know that I'm going to need to provide that using before each providers. So let's go ahead and get started by adding some of the dependencies that we know that we're going to need. Next, let's go ahead and grab all the default Jasmine imports. In fact, let's go ahead and grab that, copy it to the clipboard, and create a live template out of that, so that we'll no longer have to keep typing that out. In this particular spec, we're not going to need the test component builder because we're not going to be building a component. We're going to be building an injectable, so we can delete that. We also don't need the inject async. Now let's get started writing out our test. First, let's describe the service that we're going to be building. This service is going to need a couple of methods. Let's start out with just one of those methods right now. It's going to need a method to get all of the top albums. And it's going to use the artist to determine where to get the top albums from. Now, since this is just a dummy HTTP service, it's really enough for our implementation just to make sure that each one of these methods that we're going to write into the HTTP service is defined. Let's go ahead and create a basic spec to make sure that that's the case. Now, we're going to need our HTTP service to be injected at some point, so let's go ahead and add that up here. Now let's run our specs. Alright, now let's get started building out our service, or our Angular 2 injectable. First, let's get the injectable decorator. Now, let's build out a class that uses that decorator. Now let's go ahead and create this method. Now we can see here that our spec is giving us an error. That's because we're not exporting our class. So let's go ahead and do that. Now let's inject our HTTP service into our test, create a local version of that, and test that this is working. Looks like we still have an error. We're unable to find this inject variable, and that's because I forgot to import it. So let's make sure that we're importing that. Now let's retry. Now we have a different error. We have no provider for the HTTP service. That's because we forgot to use our before each providers block. Let's go ahead and tidy that up. Now we should see a passing spec. Now let's go ahead and take a look at building out the actual functionality for this get top albums method. Now I know that this is going to require the HTTP service that's built into Angular, so let's go ahead and import that now. Now, dependency injection inside of Angular 2 is a little bit different than it was inside of Angular 1. Instead of injecting this into an anonymous function, we're going to inject this into the constructor. And just for clarity, we're going to go ahead and inject this and name our injected variable to lowercase http. Then we're going to create a globally accessible method inside of the HTTP service called this.http and set that equal to the injected version of HTTP. Now, from get top albums, we can call this.http.get. It's at this point that we should take a look at the API documentation for the get top albums feature built into the Last.fm service. As you can see, they provide you with the link right here. I've also taken this link and pasted in our API key, and here's the data that we should be expecting back. Let's go ahead and copy this HTTP link and move it over into the HTTP service that we're building. Now we're going to want to inject this key dynamically, just for best practices. So let's go ahead and cut this key out. And set it equal to a variable. Now, since we won't be referencing this anywhere inside of this controller, let's go ahead and set this equal to a constant. There, much better. Now, while we could call this URL this way, the Last.fm API allows us to use this base URL to call a variety of different features. So let's trim this down to just the base URL. And then let's rename this for clarity. Now that we have the base URL defined, we can use that inside of this HTTP GET as a part of our URL. Since we need to concatenate some additional query strings on it, let's go ahead and inject that using backticks and dynamically concatenate this string. So now, at the end of this URL, we're going to need to add some additional information. In this case, let's go ahead and paste in the information that we had before. We can see here that the method artist get top albums allows us to pass in a variable here so that we can change the artist definition and get different data back each time. So let's go ahead and use our local instance of artist. Perfect. Now we're able to use the HTTP GET service. Now there's just one thing. I want to have complete control over how and when this data gets set back. So what I'm going to do is I'm going to wrap this entire HTTP GET inside of a promise. So when I call the method getTopAlbums inside of our injected service, I'm going to be returning just a promise. If you don't know anything about ES6 promises, feel free to read the documentation. They're fairly simple. Basically, we're going to pass in an arrow function that's going to have two arguments, the resolve and the reject arguments. Now, anywhere we call resolve or reject, we'll either resolve the promise or reject it. In this case, we'll call resolve after the HTTP GET request executes successfully. Now there is one more thing. The HTTP GET method inside of Angular 2 returns an observable, unlike the HTTP method in Angular 1, which returned a promise. We just so happen to be wrapping this observable in a promise, but let's take advantage of some of the features that this observable allows us to control. In order to do so, we're going to need to import RxJS. Now, we can map the data that comes back from our HTTP GET call. And we can make sure that it's getting structured as JSON. Then, because it's an observable, we'll subscribe to this method and pass in our success and error functions. Now we're not going to do anything with the getTopAlbums error function. We're just going to reject it and then construct an object that has a message that contains the error. For the HTTP GET though, what we do want to do is look at the documentation to see the object that's going to get passed back. Now looking at the documentation, it's actually kind of sparse. We don't really know what kind of properties we're going to be getting back from our HTTP request. However, if you take a look at the JSON, we can see that we're going to get an object back that's going to have a property of top albums. And inside of that top albums property, there's going to be another property called album. And that's going to be a repeated list of all of the data that we actually want. So inside of our resolution, we're going to want to make sure that top albums and album are present inside of the return data. So let's go ahead and do that. Perfect. Now let's run our specs and see what's happened. We're getting an error here. There's no provider for HTTP. Oh, well that's because we haven't imported it. Let's go ahead and do that now. Another error. Now, the HTTP service that we've injected is saying that there's no provider for the connection backend. Angular, out of the box, ships with a mock backend provider. So let's go ahead and import that now. Now that we have that imported, let's go ahead and provide the HTTP class to use the mock backend. Now let's run our tests again. Perfect. Now all of our specs are passing again. We're going to need several different methods that are kind of similar to this, but all of them are going to return different data. So I'm going to quickly work through adding those. There's going to be one for similar artists, get artist info, and find artists. But all of the basic functionality is going to be the same. So let's go ahead and add those. Now let's go ahead and add the methods that correspond to these different requests. Now we're going to need to make sure that they're all pointing to the right places, so let's go ahead and update them. Now that we've updated our HTTP service, let's go ahead and rerun our specs. I've noticed one small error. There we go. Now we're ready to use our HTTP service. Now that we have our HTTP service all written and spec'd out, we're ready to begin on our next service, the favorite service. Let's begin by creating the two JS files that we're going to need to build out this feature. As usual, let's start with the spec file and begin importing the things that we know that we're going to need to build out this service. First, let's start with our test dependencies. One way to make the best use of a restricted space, such as when I'm using my MacBook with a smaller display ratio, is to double-click on the File tab inside of WebStorm. This will give you a much larger display area. Now let's get to it. We're going to start with our describe block. This is going to be a service, and we're going to call the service the favorite service. This service is going to have 4 methods. Let's go ahead and test that one of those is defined. Now, we're going to need an instance of this favorite service inside of our tests, and we already know that that's going to be the case. So let's go ahead and get started by injecting that provider into this describe block. And let's also make sure that we're injecting that into this it block. Now we're going to need to make sure that it's imported. Now let's go ahead and run our spec. As usual, our first run is going to fail because we haven't defined our injectable. So let's go ahead and begin writing out that piece. First, we'll need the injectable class. We're going to go ahead and export this class because we know that we're going to need it. Let's go ahead and create that method. Now let's test that this all works. Perfect. 12 out of 12. Now let's go ahead and begin working on building out some of the logic for our favorite service. We're going to start with changing some of the setup inside of the constructor to make sure that some of the defaults that we need inside of this class are available to us. So let's get to it. The first thing that we're going to need is a storage key. Since favorite service is actually just going to be an interface between the DOM and the local storage API built into the browser, we need to make sure that we have a storage key that we can use as the key to store data with. Next, let's create a test to make sure that local storage is enabled. And I see I have a typo here. Let's change that. Now let's write that check. This is going to be an iffy with an arrow function. Here, we're going to set a simple item. Then we're going to remove that item. If all of that works, we're going to return true. If that doesn't work, we're going to return false. Now let's make sure that when favorite service is initialized, this constructor does get called and we have access to these two methods. Now let's run our specs. Now we can see that the variables that we're declaring inside of the constructor function of the favorite service are getting set. Now let's get started by defining some of the functionality of this get favorites from storage functionality. One of the things that we want to check is that this method, get favorites from local storage, returns an array of favorites from local storage when local storage is enabled. So let's write a spec that does just that. First, let's create a mock item. Now, let's use local storage directly to set this value. Now, let's create a variable from the return data from the getFavorites-from-storage function. Now let's create some expectations. We're going to expect that there's going to be 2 of these favorites that are returned. We're also going to expect that the first item inside of this collection has an ID, and that ID is equal to 1. And that the second item has an ID that is equal to 2. Now let's run our specs. And while those are running, we're going to get started authoring our getFavorites-from-storage method. First, what we should do, since we're going to be returning data out of this, is create a return variable. We're going to go ahead and return that local variable as well. Then, we need to check if local storage is enabled. If it is enabled, then we're going to get the favorites from local storage. If it's not, we're just going to return this empty collection. So let's go ahead and get the local storage favorites. Now let's rerun our tests. And it looks like we have an error. So I'm trying to reference the storage key that we have defined in our favorite service. However, this doesn't work inside of our spec. So now let's rerun our tests. Now we can see that our specs are passing. We should also create a test to make sure that when local storage is disabled, we were able to get an array that's empty. Now let's try that. Now that works. Now let's try something else. Let's try commenting out this setter to false and rerun our tests. In the spec above, we're creating some mock data and we're storing it inside of local storage. However, since we're never cleaning up any of that data, it still exists in this second spec file. So let's do some garbage cleanup. Now let's rerun this. Now we can see our specs are passing, even though we don't have this setter. However, let's go ahead and try something different. Let's go ahead and construct this mock storage favorites and set the item inside of local storage. Now let's run the spec. Perfect, now it's failing. Now let's uncomment out this setter so that we can set local storage enabled to false and rerun this test. This time it should pass. Perfect. Now let's clean this up just a little bit more. Let's import the before each method. Now, we're going to lift out this setter for the mock stored favorites into a before each block. Now we won't have to define this variable inside of both of these specs. And let's rerun our tests. Now we have a well-tested function. Let's move on to the next one. But first, let's go ahead and set the favorites of the favorite service equal to this method. Now, when the service is initialized, its constructor is going to set the local variable of favorites equal to the value that it gets from our recently constructed getFavorites-from-storage function. This function will either be getting those values from local storage, or it will be returning an empty array. Now let's move on to the next method that we need to create. This method will be a lot simpler. It's just going to be a simple getter for our favorites. Let's go ahead and modify our live template to include our inject. Now we won't have to write this out again. Now let's run our specs. Here we see that we're trying to check the equality of an array against an array. The easiest way to do this is just to check a property, like length, which should only be present in an array. Now we want to begin testing an addFavorites method. Let's go ahead and duplicate this test for the addFavorite, removeFavorite, and isFavorite functions that we're going to need. Now let's go ahead and run our specs. Let's get started with the addFavorite method. Now when I call the addFavorite method, what I'm expecting is going to happen is that I'm going to add a favorite and I'm going to cache that favorite when local storage is enabled. So let's go ahead and write out a spec that tests that functionality. For the other tests, we're going to go ahead and just skip them. Since the addFavorite method is going to use this favorite item again and again, let's go ahead and create that inside of a beforeEach function. Now, we want to make sure that local storage is setting an item, so we're going to want to spy on that. Let's go ahead and create a spy that does just that. Now we'll call the favorite service addFavorite method, and let's construct some expectations. Now what we're expecting is when I call the add favorite method, the favorite service favorites array is going to have a length of 1. It's also going to have an ID and name property of the first node of 1 and derp respectively. Then I'm going to test that local storage has had setItem called with the storage key and the JSON stringified value of an array that contains that mock favorite object. Let's go ahead and create an instance of the value that was set inside of local storage and test properties against that instance. Now let's run our specs. Now we can see all of the failures here, but let's go ahead and get started adding the behavior to add favorites. So first, we'll want to make sure that a favorite is getting added. Then, we'll want to create a temp variable of the current favorites. Then, we're going to push this favorite into the current favorites. Then we're going to check if local storage is enabled. If it is enabled, we're going to go ahead and set our value. Then, we're going to set this.favorites equal to our current favorites. Now let's run our specs. Perfect. This works great, but what if local storage is disabled? Let's go ahead and write up another spec that tests that. Now we have a well-tested add favorites function. Let's go ahead and tidy these up just a little bit. Now let's focus on the remove favorite method. Let's run our specs. Now this one should pass. Now we're going to increase the functionality of this remove favorites evaluation. Because what we really want it to do is we want it to remove a favorite item from the favorites and from local storage when local storage is enabled. In order to test this out, we're going to want to make sure that the remove favorite as well as the add favorite methods are present. We're also going to want to copy a spy from our add favorite test. Now let's make sure that our favorites at length are equal to 0. Make sure that we have a clean instance of our favorites. From there, we're going to add a favorite. And here again, we can copy this before each block to make sure that we have access to the mock favorite. Or we can take this and bring it all the way out into the main describe block. Now we can use that value. Now we want to check all of the same things that we check inside of the add favorites block to make sure that it has correctly added that favorite. Then we want to call the remove favorite function and see that the favorites.length is now equal to 0. Then we also want to check local storage and make sure that it's empty as well. Perfect. Now we're testing the values out of local storage, just to be extra sure. Now let's run our specs. Now that they failed, let's go ahead and add the functionality to remove favorite. Doesn't make any point to try and remove something if it doesn't exist in the first place. Then, we need to determine what the index is of the favorite that we're trying to remove. Here we're going to use an ES6 method. From there, we want to splice this value out of our favorites. We're going to splice one value. Then, if local storage is enabled, we're going to want to go ahead and set that value as well. Now let's test if this is working. Perfect, it's working. Now let's go ahead and make sure that this works when local storage is disabled as well. Here we'll disable local storage. I just realized that we weren't testing to make sure that local storage was getting called. We can remedy that there. And here we'll make sure that it's not getting called. Looks like one of them failed. We also want to update this. And we forgot to prepend this with the negative as well. That should finish it. Let's go ahead and clean this up and run the tests while we're doing so. Now let's go ahead and work on the very last method that we'll need for this favorite service. This method will iterate through the favorites and return a boolean if an ID is present inside of the favorites. Now inside of this test, we'll need to add and remove a favorite, so let's make sure that we have both of those at our disposal. Here we're going to add the mock favorite. Then we're going to expect this to return true. Then, we're going to remove that same favorite. We're going to expect this to be false now. Let's go ahead and run this. That's going to fail. And then this is a really simple method to write using the new ES6 sum function. Now let's go ahead and run this again. We forgot to specify the argument of ID. Now let's rerun this. Perfect. All of our specs pass. That's everything that we need for our favorite service. Now we're ready to begin using our favorite service and our HTTP service inside of our components.